Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for palindrome number problem. Let's look at the problem description. We are given an integer and we have to return true if that number is a palindrome. Otherwise, we have to return false. Let's take a look at the example 1. So the input is 121 and so the number is same when we read from forward direction as well as the reverse direction. So the output is true. In the case of example 2, the input number is minus 121 and this is not a palindrome number. When we read reverse it is 121, when we read forward it is minus 121. So it is not a valid palindrome number. So we have to return false. In the example 3, the input number is 10. So in this case it is not a palindrome number because when we read forward and the reverse directions the numbers are not same. So in the output is false. The constraints for this problem are the value of this input number is ranging from minus 2 to the power 31 to 2 to the power 31 minus 1. Okay, could you solve it without converting the integer to a string? Let's look at the approach to solve this problem. So given input number is 121 and the expected output is true. Basically we can extract the least significant digit of the input number and add it to the number called reverse number. So each time we divide this number by 10 and update it, and the remainder of that division operation will get added to the reverse number. And when we add that to the reverse number, we have to shift the digits to the left. So the current number will be multiplied by 10 and the remainder of this division operation gets added to this number. Okay, we can repeat that division operation until the reverse number is greater than the input number. For example, in this case, first time we extract this digit and add it to the reverse number. Then this number will become 12 and this number become 1. And the next iteration we divide this 12 by 10 and we get the remainder 2 and that gets added to the reverse number after shifting the 1. So the reverse number here will become 12 and the input number will become 1. So the moment the reverse number is greater than the input number, we stop that division and we can check whether the reverse number and the input number both are equal. If they are equal, they are palindrome. The input number is palindrome. Otherwise, we have to return false. Depending on the number of digits in the input number, we have to do additional checks. If the number of digits is even, for example, if we have 1221, then we can simply check the reverse number and the input number. But in this case, we have to remove the last digit from the reverse number before comparing the reverse number and the input number. Okay, for example, at the end the reverse number is 12 and the input number is 1. So in that case we have to remove the last digit, that is number 2, from the reverse number and compare the remaining values in the reverse number, which is 1. Okay, so that's what I have listed here. First we initialize the reverse number to 0 and divide the input number by 10 and assign the quotient to the input number, and the reverse number will be multiplied by 10 and then we have to add the remainder of the previous division operation to the reverse number. We have to repeat these two steps until the reverse number is greater than the input number. Once we come out of that loop, then we can check whether the number is equal to the reverse number. In that case, we have to return true. Otherwise, the number of digits, if it is odd, then we have to remove the least significant digit present in the reverse number and then compare that with the input number. So that's what the last line is about. Divide the reverse number by 10, and then if the quotient is equal to the number, then return true. Otherwise, we have to return false. Let's look at the flowchart. Input for this procedure is integer num. First, we initialize the reverse number to 0 and then the readval variable to false. Then we enter the for loop. There we check whether the reverse number is greater than the input number. If it is greater, then we break out of the loop. Otherwise, we enter the body and we divide the input number by 10. And we initialize the quotient and remainder variable with the quotient value and the remainder value of that division operation. Next, we multiply the reverse number by 10. Basically, we are shifting the digit position and add the remainder of the previous operation. Okay, and then we assign the quotient value to the input number. Basically, we are updating the number after removing the least significant digit in that number. We repeat this process until the reverse number is greater than the input number. Okay, so once we come out of the loop, if the number of digits is even, in that case the simple comparison is enough. So we just compare whether the input number is equal to the reverse number. If it is, we return true. Otherwise, we remove the least significant digit in the reverse number. This is for the case where the number of digits is odd. Okay, we remove the least significant digit from the reverse number and then compare that with the input number. If they are equal, then we return true. Otherwise, we return false. Let's move on to coding. First, I check whether the input number is negative. If so, I return false. Next, I check whether the number is a multiple of 10 and also it is not equal to 0. This is for handling the case if the input number has last digit 0, then it will not be palindrome. When we read it reversely, it will not be same as the input number. So I return false. Then I initialize the reverse number to 0. Then I write the for loop, and this for loop runs as long as the input number is greater than the reversed number. Each iteration I update the reverse number by multiplying the current value by 10 and then add the x modulo 10 to it. Basically, I extract the least significant digit from the x and add it to the reverse number after shifting it one position left. Then I divide the x by 10 and assign that value back to x. Once I come out of the loop, I check whether the reverse number is equal to the current value of x, or I check whether the value of x is equal to the quotient value of the remainder divided by 10. Basically, after removing the least significant digit of the reverse number. This is for the case where the input number is having odd number of digits. In either case, I return true. Otherwise, I return false at the end. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. The input number is 121 and the expected output is true. Okay. So first we check whether the input number is less than 0. In this case, it is not. Next, we check whether the number is multiple of 10 and also it is not equal to 0. This is for the case for all the numbers that are ending with 0. Okay, so those numbers, if we reverse it, it will not be same. So that's why we check whether the current number is not equal to 0 and it is multiple of 10. Okay, in that case we have to return false. So in this case the last digit is not 0, then we go ahead and initialize the reverse number to 0, and then we enter the for loop, and the iteration 0, when we enter the number is 121, the reverse number is 0. First we add the least significant digit to the reverse number by multiplying the reverse number by 10. Currently it is 0, so 0 times 10 plus input number modulo 10. So in this case 121 modulo 10 will give us 1. So 0 plus 1, 1. So we extract the least significant digit from the input number and add it to the reverse number in the iteration 0. Next we assign the quotient of the division operation to the input number. So that is 12. So when we leave the iteration 0, the input number becomes 12 and the reverse number become 1. Then we come to the iteration 1. We check whether the input number is greater than the reverse number. In this case 12 is greater than 1. So we are entering the body of the for loop. Again we extract the least significant digit of the num by doing a modulo 10, and then we multiply the reverse number by 10 and add that the remainder. Then the reverse number becomes 12, and then we update the value x by the quotient of the division operation. Then we update the input value, then the input number becomes 1. Okay, so now in third iteration when we check whether the input number is greater than the reverse number. In this case it is not, because the reverse number is 12 and the input number is 1. So we break out of this loop. Okay, then we check whether the input number is equal to the reverse number. It is not equal, and also we check for the case where the input number has odd number of digits. So in that case we extract the least significant digit in the reverse number, and then remaining value will be compared with the input number. So once we remove the least significant digit, we get the reverse number as 1, and the input number and the reverse number is now equal. So we return true. That is an expected output. Next I am going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for few inputs. For the case 1, the input number is 121. It has odd number of digits, 3 digits. Okay, so for this input, how many iterations this for loop performs? It performs 2 iterations. Okay, which is the number of digits in the input string divided by 2 plus 1, n by 2 plus 1. Okay, and so for the case 2, the input number is 12,321 and it has 5 digits, which is odd number. Okay, so the number of iterations this for loop performs is 3. The number of digits divided by 2 plus 1, n by 2 plus 1. And in the case of 3, we have 6 digits in the input number, even number. So in this case the number of iterations this for loop performs is 3, which is the number of digits divided by 2. Okay, for the input number with n digits, the for loop performs n by 2 plus 1 iteration. In the worst case it's n by 2 plus 1 iteration, and so the time complexity is order of n by 2 plus 1, and we can remove the constant factors out of this, so the time complexity is order of n. With respect to the space complexity, we are not allocating any additional space in this procedure. Okay, so that space complexity is order of 1. Thanks for watching this video. Have a great day.